So today we're going to take a look at calculating the compound interest the very, very, very quick way. Now, let's take a look at what we did before. So before, we calculated the compound interest using tables. Students, today we will do that no more. I absolutely don't like that. Now, before, this is what we usually did. We looked at a problem where we basically set up a table and calculated the number of years to get to our final end goal. This time, we're not using that. We are going to do a thing that calculates the total amount of money in one shot, kids, because you only have one opportunity. So, the first thing we've got to understand is that when we're talking about time periods or compounding periods, we're always referring to the amount of time, the amount of something that happens in a year. There are special words we're going to use, and they are annual, meaning for 1 year there's exactly one compounding period. For semi-annual, it means that we take the year and split it into 2 times where our interest gets compounded. Quarterly means it happens it happens 4 times a year. Monthly means it happens 12. Weekly means it's 52, and daily means it's 365 days. So here's an example from your homework that we want to use to start the work that we're going to do for our calculations for compound interest. So we need to complete the table. So when you hear the concept of the rate per annum, this means the percentage that we have for our compounding amounts for the year. Now, when you hear something that says that it's compounding annually, right? The annual amount of compounding periods for 1 year is 1, right? The rate of the compounding for the year is going to be this: 5 divided by 100, and then we're going to divide by the number 1 that we have in our compounding periods, right? And then the number of compounding periods in the year is just 6 times the number 1. So the key idea is to remember that the numbers 1 are actually used to kind of either multiply or divide our period numbers, right? So the rate per period is going to be, in this case, 0.05, and the number of compounding periods, the amount of times our money keeps increasing by that percentage, is always going to be 6 times the number of compounding periods. Now, we're going to do the same thing for our semi-annual. When we have something that's semi-annual, we literally start with the number 2, because semi means there are two times something happens in a year, right? So now what we have to do is we have to calculate our rate per compounding period. Now, here's all you do. You go 6 divided by 100 is our percentage, and then we have to divide it by, you guessed it, 2, which gives us a final answer of 0.03. Okay? And now, our number of compounding periods is the years times the compounding period. So in this case, it's going to be 4 times, well, you guessed it, 2, which gives us 8. And we use that to do our basic computations. Okay? Now, how does this stuff work when we pull it all together with our table information here, right? So imagine I give you this kind of problem, and I say to you, I want you to total the amount of money that you've made in a certain number of years. Here's what we're going to do. So you got to remember last time when we were doing our compound interest, we totaled up all our money using that table, and we always use the bottom right corner to get our final answer. We're not doing this anymore. So now we're going to use this basic equation. Now we're going to use the equation A is equal to P bracket 1 plus I raised to the power of n, where n is the number of years times the compounding number that we had here, and I is the interest per period, which is right here, okay? And P is the starting amount and the ending amount. So let me give you an example that works, that I typically use for a problem like this. Now, you're going to be doing problems that are very similar to this, and you will try the problems. They're only going to be about 3 or 4 problems, so let's go through them, okay? So remember, our basic equation is A is equal to P 1 plus I raised to the exponent n, right? Now, here is how we use that equation. So Mr. Simpson invests $10,000 into a bank, right? The bank offers 8% compounded quarterly. So let me explain to you how we're going to do this. We are going to start by writing our basic equation. Remember, our basic equation is this. A is equal to P 1 plus I raised to the exponent n, right? So in order to get this, what we're going to do is we're going to figure out what A, P, I, and N is, right? So in this case, we said that the amount that we started with is 10,000. So this is what we write. We write down all of the important letters from our equation and do our calculations on our sheet. So let's go and take a look at that right now. So when we do our calculations, we say, all right, A, P, I, N. We stick a pin in it. We take a stock of what we know from our information. So the first thing that you got to realize is that our A value we don't know. Our A value is the amount of money that we have at the end of our compounding. So the first thing that you got to understand is the starting amount is $10,000. So P is equal to $10,000. Now, the I value represents what we had here as our rate per period, right? So what we're going to do is we're going to take the percentage, we're going to divide by 100, and then divide by the type of compounding period. Now, this one is saying that our interest is 8% and it's compounded quarterly. So what does that really mean? So it really means we're going to take 8 divided by 100, then divided by 4, and that gives us 0.02. The calculations that we do today will have certain things like this. Now, the next thing that you want to do is you have to figure out the number of compounding periods. Now, the number of compounding periods is based on the number of years times the type of compounding period. And in this case, it's quarterly. So what we're going to do is we're going to do 8 times 4, which gives us 32. Now, to do our final computation, this is what we must do. Now we need to take all this information that we have for P, I, and N, and we need to plug this into our calculator. So here's how we use our basic calculator, right? So what I would like you to do is I'd like you to use Desmos or a scientific calculator to do this. Your current calculators won't quite work nicely with this. So here's what you do. So right now, what we're going to do is we're going to substitute our information directly into our worksheet, right? So we're just substituting all our numbers directly into our computation, right? And I'll explain what I mean by that right now. So now in our equation, all we're going to do is we're just going to substitute. So this time we substitute P is 1,000. Then we have 1 plus I raised to the n. So you end up with 1 plus 0.02 raised to the exponent 32, right? And on your calculator, your scientific calculator, all you're going to do is punch this thing into your calculator. Now, if you want, you can rewrite this as 1,000 times 1.02 y to the x to the 32. Okay? And now, when you punch that in, you're going to end up with this final answer. Now, remember, you're always rounding your final answer to those final calculations there. Now, if you don't have a scientific calculator, what I would like you to do is use Desmos. Now, let me quickly show you how to get to Desmos, and we'll use it in case you have some issues. So, here's what you do. You go to desmos.com for our calculator, right? Now, you can either, you don't use the graphic calculator. What we got to do is we got to go to our math tools, and we're going to use the scientific calculator. Now, in order to get our work like this put in, so remember it's 1,000 bracket 1 plus 0.02 raised to the 32. To get that onto our Desmos, what we have to do is we have to type 10,000, then we need to have a bracket. Click the bracket. Then we go 1 plus 0.02, end bracket, and then to get our exponent, this is all we do. We click this button, A to the B, right? So this raises our thing to the exponent 32, and then we get our final answer, 8,845.40, right? And we're done. Okay? That's our answer. All right? And that's it. So what I'm going to give you is a couple of questions to kind of start you into the wonderful world of compound interest. All right? Have a good day, guys.